what's alike? So let's suppose we have 3 apples plus 2 apples plus 5 oranges plus 7 apples plus 1 orange plus 8 bananas. Okay, well, apples are like apples. Yeah. So immediately I think, okay, if you're asking me what's alike, I see 3, 5, 12 apples. Yeah. Okay, what else is alike? Oranges. I see 6 oranges. I see 8 bananas. Yeah. Okay. So if we are going to maybe put that into, if we were going to translate this directly into math symbology, maybe I would say this is 3 apples plus 2 apples in addition to 5 oranges, being careful not to make it look like a 0, in addition to 7 apples, another orange, and we also have, in addition to that, 8 bananas. Yeah. So if we combine those 3 apples, 2 apples, 7 apples, I see that's where our 12 apples come from. So 3 of them plus 2 of them plus 7 of them, 12 of them. And oranges, 5 oranges plus 1 orange, 6 oranges. And then the 8 bananas, they're hanging out, 8 bananas. Yeah. So we add like with like, or we do a natural combination therein. But I would say, in addition to that, my mind says, well, they're all fruit. So maybe I didn't tag them with A, O, B adjectives. Maybe I just called them all fruit. So three pieces of fruit, 2 more pieces of fruit, 5, etc. And then I could, if I did that, it's thinking more along the lines of 3 fruits plus 2 fruits plus 5 fruits plus 7 fruits plus 1 piece of fruit plus 8. And that, so if I relabel these, there are 26 pieces of fruit, if you want to label it that way. But that required me to re-identify. If we wrote it like this, okay, that works. If we want to keep them, as separate labels. What about 3/5 plus 2/5 minus 1/5? Okay, well, 3 of them plus 2 of them makes 5 of them, minus 1 of them makes 4/5, right? And if we're going to write this with actual fractions, 3/5 plus 2/5 minus 1/5 makes 3 of them plus 2 of them makes 5 of them, minus 1 of them makes 4/5. Okay, so when I think about these equal portions, I can also think of them as, alike things because they are equal portions. So they have a similarity, a similar adjective describing them. Semester tuition is $125 per credit, plus an instructional technology fee of $20 and a printing fee of $10. Write an expression describing the cost and then simplify it. Okay, so TC, or total cost, will be $125 per credit. So $125 per credit times a number of credits, because here, right, if you take 2 credit hours, it's $250. If you take 3, it's $375, etc. So because it's per credit, I'm thinking, okay, you have to times it by however many credits. So let's put this as number of credits, right? plus a technology or instructional technology fee. Okay, so there's a tech fee and a print fee. Okay, and it looks like this one is a little bit different because it first has to be multiplied or scaled up by how many credits. You take more credits, you pay more. But these are kind of flat fees, so they don't get scaled up based on how many credits you take. It's just 30. So 125 C per credit plus 30 bucks extra. Okay. And here, 7 grams of protein plus 15 grams of protein. How many does that make? Well, I see 22 grams of protein. Voila. Okay, next. I'm sure we have more. Okay. 4 inches plus 8 inches on it. 4 plus 8 makes 12 inches. Or if you like, you could relabel this because we know about equality, and that would be 1 foot because 12 inches makes 1 foot, like a ruler. 2x's plus 7x's minus 4x's. Okay, so 2x's plus 7x's minus 4x's. How many x's do we have? 2 plus 7 makes 9. 9 minus 4 makes 5. And there it is translated. Deduct $10 for each dependent for insurance, and then deduct an additional $25 per dependent for childcare. Okay, that sounds like something straight from taxes. Number of dependents. As a matter of fact, I might have been doing taxes when I was typing this. So deduct $10. It doesn't say from what. So it's some previous amount. So I'm actually going to write that amount. Deduct means take away, amount minus, okay, 10 for each. Okay, so $10, but D times, right? Because if we had 2 dependents, we would do this 2 times. If we had 4 dependents, we'd have a busy house and we would have 10 taken away 4 times. Oops. And then deduct an additional $25 per dependent for childcare. Okay, so like that. So it looks to me like we would have whatever the initial amount was, but take away, I mean, if we deducted 10 for each dependent and 25 for each dependent, really we are deducting 35 for each dependent. Okay, let's see. $7 plus 76 cents. Well, I want to, let's see. We could either turn this into cents so that they're both cents, or we could turn this into dollars. We're going to do them both. $7 is 100 cents or 700 cents plus 76 cents, which makes 776 cents. Got it. Or we could have turned this into dollars so that they are alike and said $7 plus $0.76 because there are 100 cents in a dollar. And so this is tenths, hundredths place. And that is, so now we have dollars plus dollars. So we have $7.76 or $7.76. Okay, what I want to warn you of is this. Don't get into the booby trap of this does not equal 83. No, I don't know how else to make these eyebrows. Maybe I should have made like teeth-y, whatever. And now when I look at this, I see a dog, but whatever. Just you can't add them because, or to get 83, because what would you say? $83? That's outrageous. Or 83 cents? No, man, don't shortchange it. Anyway, or woman, 3 minutes, take away 43 seconds. Again, we have a disagreement in labels. Okay, so we're going to have to, but they have commonality. We just have to rewrite them, emphasizing their commonality. So 3 minutes, take away 43 seconds. Let's write it 3 minutes so that we can see that they actually don't look alike right now. 3 minutes minus 4, not 4, 43 seconds. Uh-oh, which is equal to, okay, there are 60 seconds in a minute, and there's 3 of them. So 60 and 60 and 60 makes 180 seconds minus 43 seconds. Okay, now we're like and like, and we can take away. Just thinking out loud, first I would subtract. This is just how I do head math. First, I would take away 40 seconds, but I still need to take away 3 more. So without getting out my calculator, which I don't even know if I have it, is 137 seconds. Okay. And you could easily turn that back into minutes if you wanted to. Let's do it quick. Why not? Or, you know, how many minutes is that? 2 whole minutes, because that's 120. So 2 minutes and oopsie, and or plus 2 minutes and, okay, what, 17 seconds? Beware. So random beware that this would not be, if we turn this into minutes, this is not 3 minutes take away 0.43 minutes. Beware, because there are not 100 seconds in a minute. It would be 3 minutes take away 43 out of 60. That would be the correct portion, okay, if you wanted to go down the minute path. I found the seconds to be friendlier because they are non-fraction, honestly. Whatever. We all have our likes and preferences. 2 hours plus 4 miles. What? Okay, just, these are not alike. They're very different. Time and distance. Nope. Not adding them. Maybe as a ratio, but plus, I question that. 3 feet plus 16 inches. Now, these have some commonality. These have some likeness to them. There are 12 inches in 1 foot. So my first instinct is to say, okay, 1 foot equals 12 inches. 2 feet equals 24. 3 feet equals 36 inches. So 3 feet plus 16 inches. And I'm doing that because it's the without the fractions again, FYI. I'm going into the smaller portion so that I have whole number answers. So 33 feet. So 3 feet plus 16 inches is equal to 36 inches plus 16 inches, which is equal to, okay, add 10, and I would have 46 inches plus 6, and then add an additional, well, if I do 4, I get to 50, and then 2 more, so 52 inches. And done. If you need this in feet, of course, well, then 4 feet would equal 48 inches. There's a 4 difference. So 4 feet and or plus 4 more inches Okay. Or you could write this as a fraction because there's 4 inches. And anyway, I'm just going to go here because my focus really is on finding common ground. Let's see, or seeing how they're alike, not focusing on how they're different, trying to focus on how they might have something in common or be alike. So 7/8 take away 1/2. Yeah, I'm going to need to turn this into 8 portions. And I can do so by scaling up or cutting it into more pieces. So that is 7/8. 1/2 is 4/8, or 4 out of 8 is, yeah, half of the thing cut into 8 equal portions. And now I can do this. 7/8 take away 4/8 makes 3/8. Voila. 18 grams of protein plus 2 grams of fat. Not alike units. Not common. They do not have their basic characteristics in common. I mean, nutrients maybe. But protein, fat, nope. Got it. So what about this one? Ooh, now we look for the common. So we have 2 x's, take away 6 x's, I see. Okay, 2 x's, take away 6 x's. Then we're going to be in debt. We're going to be in debt by 4 x's. Whatever these x's are, we would have a debt of them. And then 4 y's plus 3 y's. Oh, we have additional y's, 7 y's. And then what else do we have? We have 5 of what, like 5 and take away 9. So then we also have a debt of 4. So take away 4 more for floating things, whatever. Does not have a label. Cannot be labeled. Okay. Let's see. Now we have to duplicate because this is 5 sets of 2x plus 4y. So 2x plus 4y is being added 5 times. So I'm going to distribute. So if I added 2x 5 times, I would have 10 x's. If I added 4y 5 times, I would have 20 y's. Now take away 5x 3 times. So take away 15 x's because I took away 5x 3 times. Take away a debt. So taking away a debt makes them into positives, just gains. So 8y 3 times. So gain 24 y's. Take away 4 3 times. Take away 4 3 times means you took away 12. Any commonality? Yeah, we got x's and x's and y's and y's. All right. So we have 10 x's. We take away 15 x's. We are down by 5 of them. Keeping their label. Keep the label. I mean, we don't want to add protein and fat and then have a mix of unlike things, whatever. Anyway, sometimes we like a mix of unlike things, but we just write them that we are mixing unlike things. So 20y plus 24y, those are alike. So really what we're doing is we're having a gain of 44 y's. And then it looks like this is the only thing that hasn't any common label as the rest. So we can combine them like it's shown here or put them together, but still acknowledge that they are different. Okay, cool. Let's see here. Okay, I am not scared of fractions. So I have to take half of, so take away 4x, half of a 4x. Well, if I have a half of a 4x, that's 2x. So I'm really doing 5x. Take away half of that is 2 x's. Take away half of a debt of 6. Taking away a debt is a gain. So I'm actually adding, but half of 6 is 3. Okay, 5 x's take away 2 x's. Those are like, this one is not exactly the same as the others. but still we can put them together. 5x's minus 2x's is 3x's. So here I've written it, so it's still put together. It's just that we don't combine them because we acknowledge their difference. Cool. Let's do it again. Right? Let's do it again. So here we go. I'm going to use that distributive. I am taking away 2x's. I am taking away a debt, so a gain of 2 sets of 6y, so 12y. I am taking away a set of 5x, and I just put in an adjective. It's which is really 1. Okay, and I'm also taking away 1 set of 3y and plus 10. Traditionally speaking, most teachers will say, okay, you multiply like this, yeah. Careful with the signs. I like to say it out loud sometimes just to remember why those quick computations work. But anyway, a negative 2x, a debt of 2x's, and then more debt, so negative 7x's. 12y take away 3y. Okay, sure, you can take some of those y's away. And then plus 10. A rectangle has sides. Okay, I'm just going to go as I go. I don't know what's up. 9 centimeters, 5 centimeters, 9 centimeters, 5 centimeters. What is the perimeter? So when I think about, oh, I'm going to walk the perimeter, that's walking along the outside. So that is the distance around the outside. Well, 9 plus 5, let's write it. 9 centimeters plus 5 centimeters, which is 14, but that's only halfway around. 14 and 14 make 28 centimeters all the way around, which equals the perimeter around the outside. How far does it take to walk around the outside? It is 28 centimeters, but that's not actually a walk because centimeters are tiny, right? Like the size of my nail bed. Anyway, a triangle has a perimeter of 24 inches. I think the marker of a centimeter or is like the pinky usually, but obviously that depends on how big your hands are. Hence the name foot, which is like, oh, well, it's the king's foot, of course. Anyway, a triangle has a perimeter of 24 inches. Oh, so it's 24 inches around. And I don't know how the triangle looks, so I'm going to try to not make many assumptions on it. And, I don't know what it looks like. Anyway, we know that it's 24 inches around. So one side of the triangle measures 4 inches. Another side measures 11 inches. How long is the third side? Yeah. Well, we know that 4 inches plus 11 inches plus who knows the third side, we will in a minute, will equal a total of 24 inches. Okay, 11 inches plus 4 inches makes 15 inches. What is that, 9? Niner. Third side, 9 inches. So how long is the third side of the triangle? 9 inches. Okay, so let's talk about what it means to simplify an expression. To simplify an expression, we perform operations on expressions. So combinations of variables, numbers, and exponents to simplify or make it look easier, but not change. evaluation for future computations. So you haven't changed what it actually equals to. And I'll make a remark here. So quick recall, right? We add apples to apples. Whoops. My P got out of control there. And milligrams to milligrams, right? But we have to make sure that they're, even if we're specifying, we have to make sure that they're alike. So, right, we didn't combine protein to fat, but we can do protein and protein. Similarly, we could, anyway. So what I want us to recall is like objects or like units. So we add things. Okay. We acknowledge their commonality, basically. So then we say, oh, we're going to combine like terms. We're saying how they are alike. So when I think about combining like terms, we are adding and subtracting and or, I guess, pieces, aka the math term or the math vocabulary is called adding and subtracting terms, but I kind of like the word pieces of an expression. With like units. Yeah. So let's look at this next example. Okay, got to get my calculator out. Here it is. Ta-da. And it says calculator check. So simplify 3 times a quantity 2x minus 3 and then minus 5. Got it. I'm going to try my best. So 3 groups of 2x's is 6x's, or 2x's plus 2x's plus 2x's makes 6x's. 3 groups of -3. So add together 3 -3s, you would be down by 9. So you have a debt of 3 times. Yeah, you're down 9. And then also there's a takeaway 5. So the x's kind of are not exactly like the others. They're together with, so they're related to, but they are not like the others exactly. And a debt of 9, a debt of 5 is a debt of 14, I believe. What do you put into your calculator to check this? Write a process for how to put this into your graphing calculator. Okay. First step, turn it on. Here we go. Here's what we're going to do. We are going to go into, oh, wow, I have a lot of stuff in here. I have to turn everything off. Okay, I just cleared everything and turned everything off. If you see that on your calculator, I highly recommend you do that. Let's see. We're going to type in the original. So I did 2 parentheses and then 2, here's the X button right there, 2x minus 3, and then minus 5. Notice how I copied it verbatim. Then I'm going to put in y2, my simplified version, 2x minus 14, and hit enter. Okay, so far, what did I do? I went to y equals. I put in y1 equals, and then I put in y2 equals 6x minus 14, right? And now what I'm going to do is I'm going to hit zoom and I'm going to hit go to standard. I like to start with standard and see if I can see the graph. If I can, I'm great. Oh, there is the first equation. Oh, I don't know if you saw it happen, but the other one, the second equation, which was in red, lined up on top of it, perfectly matching it. Okay, so I'm going to show that again, but first I'm going to write down what just happened. What just happened? So, step one, graph the original and simplified version, which is why I put this into Y1 and this in Y2. Okay, and then check to see if they match. If yes, you combined correctly. Okay, so here, let me do this again, but I'm going to zoom in even more on this calculator. Okay, second quit. And now, okay, it just went right back. Here, I'm going to clear this and I'm going to graph this. I'm going to redo this so that you can visually see it. Okay, there's blue. That's Y1 before we did any simplification. And then we got 6x minus 14. And now I'm going to graph. So you see the original, but watch, here comes the second one. There it is. It lined up perfectly. So that's how you know we combine these correctly. Let's suppose for fun, I accidentally said, okay, 6x minus 14 is now negative 8x's. So I didn't acknowledge their differences. And I said, you know what? This one, it wasn't that, it's negative 8x's. And then I go to graph. Okay, we see here comes the first one. There's this equation. Boom. No, my friend. I am so tired of that, my friend business. We don't know each other, okay? I don't want to be cavalier with the word, but I acknowledge that you are hearing me. But anyway, no, that is not the same. These do not represent, they will not simplify for future computation. Okay, hold on. We did not acknowledge this. These are not equal. I should have put something about equal. This is what we do to simplify. Maybe I should have added something about doing it correctly. If we did it correctly, they would line up and match and be equal to each other. Okay. Oh, my bad. I got ahead of myself. Write down Y1 and Y2 and draw this graph of the sketch here. Okay. Right. Let's do that. So, what did we put into Y1? The original. And Y2, what we had simplified it to. Yeah. And then just a quick rough sketch. I remember it did blue line, something like that. And then it was like, oh, you know what? And here comes the second one. It's red line and it's right on top of it. Match. Done. Use the table feature on your calculator to check for equivalence. Okay, well, of course, my curiosity got the better of me, so I better go back to this, do my graph. Okay. So there's the blue and there's the red. My mind just assumed that eventually they would cross down here. Use the table feature, put the table here, ready. So notice right above this graph, so it goes second graph, and you will get this table. You can go up and down on this table, however you like. But let's make it right now. Let's put that down. So, oof, the glare of my light is shining bright. Y1 and Y2. This will be enough. So they both are equal. So notice the Y values. So you put in X equals 0. And for each of these, you'll get negative 14 out. Put in 1X, you'll get negative 8 as a response. Put in 2, you'll get negative 2. Put in 3, you'll get 4. Look at all of that. And what I notice all the way down is this matching. Yeah? And that's how I know that they are equal to each other. So yeah, all the way down the chart. And so that means we put this into Y1. So that means 3 times 2x minus 3 minus 5 was truly equal to 6x minus 14. Check it out. All right, let's do it again one more time. Simplify 7, take away 1 set of 4x plus 1. I will. So 7, take away 1 set of 4x's, take away a positive 1. Well, that would still be a take away 1. Got it. And I claim 7 take away 1 is 6. And we should acknowledge that we have 4x's, but they are slightly different. We want them together, but they're different. Okay, here we go again. Says write down Y1 and Y2 here. You bet. Y1, I'm going to write down the original. Y2, I'm going to write down my claim to how it beautifies, simplifies. I mean, sometimes complicated is beautiful too. But, okay, I'm getting ready to see what happens. All right, back to the calculator. Y equals, so just so you're crystal clear, I went Y equals. Clear. 7 minus 4, and don't forget that the X is right here. Man, I put 1. 7 minus 4x plus 1. Got it. Enter. 6, take away 4x. Enter. And I'm going to go zoom down to standard and hit enter. Here we go. Here comes the first one. Voila, blue. Thank you. And yeah, did it right. Matchy, matchy. So, rough sketch. Meow. Oh, wow. That really, when I combine those two, they really look black on the screen. There-ish. Match. Hurrah. Use the table feature to show the equivalence on it. So, again, so that's second graph. And here's what we see. And it doesn't matter. I could even dip into the negatives. Why not? I'm going to go for fun. -2, -1, 0, and 1. Why not? So 14 is equal to 14. 10 is equal to 10. When x is 0, they are both 6. When x is 1, they were both 2. Yeah. Beautiful. So y1 equals y2 means 7 minus 4x plus 1 is equal to 6 minus 4x. Yay! Beep, beep, beep. Yippee! I don't know if you want to call that hair or excitement coming out of your brain, whatever you like. Okay, so overall in this section, when I think about it, 1.2, we computed and interpreted the change of a quantity, and we had special care with the signs. We identified units and let them be meaningful and to describe the relationships between these things. We simplified them. So, sometimes you can combine things that are perfectly alike, but you should still acknowledge when they have slight differences. We evaluated by plugging in values when we didn't know them and checked for equality. And sometimes we interpret the answer in the context of what's actually happening, such as apples or temperature. And we actually even used a graphing calculator to verify equality among expressions. It's a nice check. It's reassuring that we acknowledged everything we should in the right way. All right, on to the next.